Hello everyone, my name is Matthias. I'm the technical support engineer for Trimble's eCognition software, and today I will show you a fancy algorithm within eCognition which is called layer arithmetics. And with this algorithm you can calculate your raster layers on a pixel level within eCognition. First I will show you a few small examples of how you can use the layer arithmetics, and then finally we're going to calculate the Ndvi, the Normalized Difference Vegetation Index, which is widely used for vegetation mapping. So this is going to be actually an eye-opener for those who are still calculating rasters outside of eCognition, and you're going to love this algorithm. Let's have a look at it. So in this project I loaded a raster already with 4 bands, blue, green, red and near infrared, which we're going to need for the calculation of the Ndvi. And now in the process tree we're going to append a new process, and we are looking for the algorithm layer arithmetics. There we have it, and if you click on it we're going to have these algorithm parameters. Okay, so we have the output value which is set to 0 by default, so we're going to calculate a raster with only values of 0. The output value can be a number or an expression. So in my case, I just choose 0, so a number, but it could also be a formula, an expression. And an expression starts and ends with quotation marks. Just like quotation mark, formula, quotation mark. All right, let's go back to eCognition. The output layer is set to Arithmetics. This is the name of the new raster layer, so we're going to call it Ndvi. And then we're going to change the output layer type to 32-bit float, because the Ndvi usually ranges between -1 and +1. Hit execute, and we have to go to our layer mixing window to see that we have a new layer calculated called Ndvi. And I'm going to split the view and display the Ndvi on the right hand side. In our case at the moment it has only values of 0, so it's not very useful yet, but it's just to show you the functionality. And you also could change the output value from 0 to 100, and you would have a raster with values of 100. But we're gonna do something more fancy, so we're gonna enter a formula, a very simple one at the beginning. We just type in red. And let's pause the video here for a second. I just want to mention here that I renamed my layer aliases from the default naming, layer 1, layer 2, layer 3, to their respective band names, in my case blue, green, red and near. So if you gave them different names, you also have to type in different names here, because if you don't have a red layer or layer called red, this wouldn't work. Okay, let's go back to the algorithm. So the result is that the Ndvi layer now has the same values as our red layer, because red was defined as output value. Now we can insert a bit more complicated formula. Let's say red plus green. So it's gonna create the sum out of these both layers. And now we have higher values than before, in my case. And now we're gonna enter simply the formula for the Ndvi. And all of you should know that formula. It's the near infrared band minus red divided by near infrared plus red. And this finally gives us a range between -1 and +1, and we call that one the Ndvi. I had a mistake in there, so now it's corrected. So high values correspond with vegetation, healthy vegetation, close to 1, and low values with non-vegetated areas. And non-vegetated in this case is blue, and a high Ndvi value in my case here is depicted in red on the right hand side of the window. Okay, as next little step I want to show you how you could mask out different value ranges also with the layer arithmetics. Therefore we're going to define here in this algorithm as input layer our Ndvi, and we want to set values between 0 and 0.5 to 0. So we define minimum as 0, maximum as 0.5 and output value as 0 as well. we're gonna overwrite our existing Ndvi layer, and this actually results in something like this. So all values between 0 and 0.5 are reclassified as 0, and only values higher than 0.5 or outside of that range are still there. But let's go back to our initial Ndvi layer, and as a next step I want to show you that you can use these layers that you're calculating within eCognition for segmentation input or classification. And in this case I'm going to show you how to use it in the multi-threshold segmentation. In the multi-threshold segmentation you only can use one layer. In our case we're going to use the Ndvi, and I'm going to define 3 different classes: low, medium and high. I'm going to put all values lower than 0.5 into the class low, values between 0.5 and 0.75 into the class medium, and all values higher than 0.75 into the class high. Okay, hitting execute. Now we have already objects that are classified. So we have the 3 classes, low, medium and high. And this is solely based on the Ndvi that we previously calculated with the layer Arithmetics algorithm. Let's change the values a bit, because I think we have the class low is too large, and just execute it again. Now it looks already nicer. As last step in this video, I want to show you that you also can use Boolean operators within the layer Arithmetics algorithm. So we're just going to append a new process. We're going to look for the layer Arithmetics algorithm, and we're going to enter as output value Ndvi larger than 0.6. Don't forget the quotation marks, that's very important. Output layer name, we're going to also enter Ndvi, so it's going to override our Ndvi layer. And output layer type 32-bit float. Doesn't make sense in this case, but let's just use it. Okay, you also could have actually changed the settings here all the way in the process properties window, so you don't have to go into the process itself. You can also add child processes here, or append a new process with these plus icons. You can also execute it with this play button. That's what I did right now. And here you see our results. So we have a raster with only zeros and ones. So 1 corresponds with true, so the condition is true. The Ndvi value is higher than 0.6. And 0 corresponds with it's not true. The value is lower than 0.6. So we kept it fairly simple in this video. I use basic operations and Boolean operations, but you can use all these operations listed here. This is actually taken from the reference book. So if you want to have more information, please check the reference book or the eCognition community. There you will find also a rule set which explains the capabilities of layer arithmetic step by step. So that's the end of the video. I hope you enjoyed it. Please now go ahead and use layer arithmetics for your analysis and within your projects. It's fun to use, it's very powerful, and it's gonna make your life way easier. So if you have any questions or comments, please post them and we're gonna be happy to answer them.